Problem number 14 says, evaluate the limit using L'Hopital's rule if necessary. We have the limit as x approaches 0 from the right of x to the power of 9 times sine of x. Well, we can start off by saying that this is equal to y. And the trick for this problem is to take the natural log of both sides. So the natural log of y is equal to, and when we take the natural log of the right hand side, the natural log function can move in the limit function. So I'll write it as the limit as x approaches 0 to the right of the natural log of x to the power of 9 sine x. Well, this is the same as 9 times sine of x times the natural log of x, because there's a rule that says when we have the natural log of some number to some power, we can bring that power out as a multiplier. And so the next step would be try to rewrite sine of x. So I know that sine of x is the same as 1 over cosecant of x. But this is just the same as now, as we take the limit as x approaches 0, we notice that the natural log of 0 approaches infinity, and cosecant of 0 actually approaches infinity as well. And so what this means is that we can apply L'Hopital's rule. We can apply L'Hopital's rule now. And so now we have 9 times the limit as x approaches 0 to the right of the derivative of the natural log of x is just 1 divided by x, and the derivative of cosecant x is negative cosecant x cotangent x. Now let's use some algebra to rewrite this again. So this is like 9 times the limit as x approaches 0 from the right of 1 divided by x, but we're also dividing by cosecant x is like 1 over sine of x. So this is negative 1 over sine of x, and cotangent x is actually cosine over sine. And so what that means is I have a negative cosine of x divided by sine squared of x. But we could rewrite this one more time. So this is like saying 9 times the limit as x approaches 0 of, well, 0 from the right of sine squared x divided by x cosine of x will be negative x cosine of x. And so now if we look at the form, it's still in L'Hopital's form, and so what we should do is apply L'Hopital's rule again. So this becomes 9 times the limit as x approaches 0 from the right of sine squared of x. The derivative of this would be 2 sine x cosine x all divided by, and I'll box this off to all divided by the derivative of x times cosine of x. Well, we have to use the product rule, so this would become negative x sine x plus cosine of x. And now when we plug in a 0, we have a 0 over 1. And so what that tells us is that the limit is 0, and so this is equal to 9 times 0, or 0. But if we recall from the beginning, we took the natural log of both sides, so the natural log of y is equal to 0. Well, we can use that. We can use a property of what it means to be a natural log. So this is true if and only if e to the 0 equals y. And so this would give us the value of y equals 1, or the limit is 1.